All right. I got a question regarding delta function squared in the formula during the derivation of the Fermi's golden rule, and let me explain that part once again. The transition probability from the initial state to the final state is the square of the amplitude, transition amplitude. That was 2 pi squared VFI squared delta function squared. And transition rate, gamma from I to final state, is the ratio of the probability, transition probability divided by time. And actually we consider the case the transition period capital T going to infinity. If transition probability is constant, then the transition rate will be 0 because finite 1 divided by infinity is 0. But actually, transition probability from the initial to final state has the delta function squared. And if I make use of the fact that delta function multiplied by delta function, and here actually arbitrary function, should be delta function multiplied by the function where the argument is replaced by 0, because they have the same argument, the EF minus EI. And actually delta function is not a function, it is integrable. However, the value at 0 is infinity. So if I substitute the fact that it is infinity, the transition rate is some constant multiplied by a delta function multiplied by infinity divided by infinity. So it is impossible to compute the transition rate in such a way, because infinity divided by infinity can be arbitrary in many cases. For example, if I take the ratio of x over x, as x goes to infinity, it is just 1. What about 2x over x? It is 2. What about x squared over x? It is infinity. Exponential x over x is infinity. And x over x squared goes to 0. So we have to, in this case, in such a case that infinity ratio to the infinity, we have to take the ratio in the finite limit and then take the infinite limit. So we have to evaluate the ratio at the finite interaction time capital T, and then after that take the limit of T goes to infinity later. So what I suppose is rewrite the delta function, energy delta function, in this way. Take the limit T goes to infinity, but this part is for the finite interaction time T. So assume it is integrated over minus 1/2 t to plus 1/2 t of exponential I EF minus EI t over h bar, right? This delta function can be written in a finite term, finite one, where we take the limit capital T goes to infinity. So let us take the ratio for a finite capital T. The transition probability Pi to F for a finite piece is just this. So we just rewrite this guy by making use of this, our parameterization of a delta function. There are so many ways to express the delta function, but this is the simplest way. So we just substitute this guy to delta function twice. And I have two time integral. I used a different variable, t and t prime. Okay? And 2 pi squared in the numerator has been divided but cancelled by this 2 pi squared, and I have h bar squared instead. All right. We can find it among we have two delta functions, but we can treat this guy one thing by taking the limit t goes to infinity. So I can treat this guy as a delta function. However, the other guy is kept finite. When the delta function is given, EF minus EI gives all the EF must be the same as EI. If I substitute this back in here, this integrand becomes 1, just 1. So this integral of this 1 from minus 1/2 t to plus 1/2 t is actually just t. And we have denominator capital T. So this infinity divided by infinity is just this one instead of the remaining pieces. So final result is like that. That is the same as the Fermi's golden rule. That's it.
페르미 골든룰에 대해서는 설명 저번 안 했어요.
Let us talk about it later because we will keep on studying Fermi's golden rule.
예.